Hi, this is Mr. Zachary, and this is problem 20. The elephant we don't worry about, and so block starts up here. We see that yes, it would have gravitational, no, not kinetic, and no elastic. No kinetic because it's not moving yet. No elastic because the spring isn't stretched or compressed yet. But it is above where we would set height 0, which is down here. Um, B is where it's just about to hit, and C is where it has hit. So it asks about how far does it compress. So we'll talk about point C. No for gravitational because it's at height 0. No for kinetic because the spring will bring her to a stop. And yes for the box to a stop. And yes for elastic because the spring will have been compressed. So if we look at that, we can say that the total at A is equal to the total at B is equal to the total at C because nothing interferes. So the gravitational potential energy at A must be equal to the elastic potential energy at C because there aren't other types here and there aren't other types here. So those two things have to be equal. So mgh at A equals 1/2 x squared at C. Putting in the numbers, and we get that the spring must compress 1.7 meters it as it goes. Now, the second part of the question asks about if the spring is 40% efficient to get energy back out, how high will it go over here? So we have to first say, I'm sorry, 30% efficient. The first thing we have to say is, well, how much energy did we put in here? So the answer to that is we can look at how much energy there was at point A or point B or point C because they're all the same beforehand. And we can see that the total energy at point C is 144.5 joules. The way did it was just 1/2 times 100 times 1.7 squared. And if it's 30% efficient, then we get 30% of that back out. And so we get 43.4 joules back out the spring. Now all of that will eventually come up here and turn, it'll be in kinetic, but it will turn into gravitational potential as it goes up the ramp. And so how high up the ramp will it go? Well, where it stops up here, the highest point, the elastic will no longer be uh, anything because the spring won't be compressed or stretched. The kinetic energy will be 0 because it will have stopped at the highest point. And the gravitational will be all of the energy that we have. So all of it must be must be gravitational potential energy. So how high is that? Well, we can say gravitational at D is mgh. And plugging in the numbers, we get that the height must be 1.45 meters, is how high it must go afterwards, if it's 30% efficient.